Okay, here we go. A very quick review over some of the non-calculator problems that you're going to see on the non-calculator part of the test. So this looks pretty basic. It's just asking you to simplify. It's not an equation. But the first thing we want to notice is that we've got a root stuck within a log. We don't like that. We love it when there's an exponential stuck in a log, but not a root. So our first step is going to be to rewrite this log problem so that instead of a root 4, we're going to write it as an exponent. How can we write root 4? We can write it as 1/4. That's the same thing, right? The 4 in the denominator of the exponent is a root. And so our last part is just to say, hey, what's our base? Well, if there isn't a base, it's because it's base 10. So you can finish up this problem one of two ways. You can either say, hey, when I have an exponential stuck inside a log and the base of my log is the same as the base of my exponent, I know that my answer is 1/4. That's your answer. But let's say that you, for some reason, blanked out on that. The other way that you could look at this is this. You could say, well, I have a log problem, and I can set it up as a log problem that I want to switch to an exponential. So remember how we did this in 3.1? I said equals a box. And so we set up it as an exponential 10. We always use the base of the log as the base of the exponential. 10 raised to the what power gives us this part, 10 to the 1/4. Well, this makes sense, right? 10 to the what is the same as 10 to the 1/4? Well, 10 to the 1/4. So either way you do it, you'll get 1/4. You may want to look back at the 3.1 video tutorial because it explains this problem. And now what I want you to do is write this problem down on your sheet, whatever you're working on. That looks kind of funny. It looks like that's really just supposed to say log. Somehow that looks a little weird. So I want you to write it down, and then I want you to pause, do it on your own, and then check in back with me when you have it done. Okay, so once again, I don't like it when I have a root and it's stuck in a log problem, so I'm going to rewrite this problem as instead of the square root of 8, I'm going to write 8 to the 1/2. Once again, if I have an exponential stuck in a log and the base of my log is the same as the base of my exponent, then I know that the exponent is my answer. Or once again, you can set it equal to the box and solve it that way. Either way. All right, the next type is where we have the natural log. Now, there are two different ways to solve this. The first, I'm going to use the way that I taught in 3.1, and that is, hey, it's a natural log. Let's go ahead and set it up with another way to write natural log. That's right, log base e. I'm just going to rewrite this whole thing and set it up equal to what? What is log base e of 1 over e to the 7th? Well, I can write it. I can change it into an exponential. So e to the what equals 1 over e. How did e turn into a 6? 1 over the root e raised to the 7th power. And so I can basically say, hey, what did I raise e to make it look like 1 over root e to the 7th? Well, I know that if e used to be in the numerator and now all of a sudden it's in the denominator, I know that there's a negative involved in the exponent, right? I also see that e is being square rooted, so I know that there's a 2 in my denominator. And I also see that e has been being raised to the 7th power. So there you go. E to the negative 7 over 2 is the same as 1 over root e raised to the 7th power, and my answer would be negative 7 over 2. There's actually 3 ways you could do it. The next way would be to just use the same strategy we did with the first problem and say, I don't like it when I have a root in my log problem. And so how could I rewrite this? Well, I know that the root of e to the 7th, so I'm just going to kind of over here rewrite this, and then I'll put it back in the natural log problem. So I know that I could rewrite this bottom part as 1 over e to the 7/2, right? And then if I want to get e up to the numerator, I know that I have to put a negative in front of my equation, I'm sorry, in front of my exponent. And then I know that natural log is log base e, and if I have an exponential stuck in a log and the bases are the same, then my exponent is the answer. All right, and a third way. So this, let's use a pretty color. Let's go orange since we're getting close to Halloween. So my third way is a way that Catherine, 8th block, did it, and I thought it was very ingenious. She decided to use what she knows about expanding logs. And so she said, well, if I've got natural log of 1 over root e to the 7th, I could rewrite that and expand it as natural log of 1 minus natural log of root e to the 7th. And so we could look at this, and we know natural log of 1 is the same thing as log base e to the 1. And we learned still in that 3.1 lesson that, right, log of base e of 1, we're saying e to the what equals 1? Well, e to the 0. If you don't remember that, go back to that 3.1 tutorial. And then over here, we're going to change natural log to log base e, and we're going to change e to the 7/2. So once again, you're still going to have to know that a root is the same thing as an exponent with the 2 in the denominator. And of course, we have the base and the base the same. It would be minus 7/2, right? Because the minus I'm bringing down, and the 7/2 is that. So there you have it, 3 different ways. So let's go ahead and see if you can write this down on your paper. Try it on your own, pause this, and then come on back and see if you have it right. Okay, so I think the way I'm going to choose out of the 3 ways, I'm going to choose to rewrite this part so I don't have a root in my log. So I'm going to say natural log. I know that the bottom can be written as e to the 4/3, right? Because the cube root is 3 in the denominator of the exponent. And I know if I want to bring the e up to the numerator, that means I have to rewrite with a negative, right? Because that negative in the exponent makes whatever the base is flip to the opposite part of the fraction. So if my base originally was in the denominator and I put a negative there, it flips it up, right? Can you see that these 2 things are the same? And then one last thing is I'm going to remember that natural log is log base e. And I see that I have an exponential caught inside a log. Bases are the same, therefore my exponent is my answer. Okay, so let's look at what happens when we have something like this. Let's pick, I always like that hot pink. Oh, that looks good. All right, so here we could go ahead and do just like we learned in 3.1. We could change the log into an exponential. 5 raised to what power gives me 1 over 125. And the way to look at this is to say, wait a minute, how did I make 5 be equal? What did I do to 5 to make it be equal to 1 over 125? Well, first of all, I know, since I see the 125 in the denominator, I know there's a negative. I'm going to make this box bigger. I know that there's a negative at work in our exponent, right? Because right away that negative says I just changed 5 to 1 over 5. Now, what did I do to 5 to make it equal to 125? Well, let's see. I did 5 times 5, that's 25, times 5 is another 125. So 5 to the 3rd power gives me the 125, and that negative means that it's 1 over 125. Now, you can certainly go about this a little bit differently. You could always take the 125. I was working from the 5 and going this way. You could always take the 1 over 125 and try to rewrite it, right? You could do it this way. And then remember that the exponent is our answer. All right, so go ahead and write this next one down and pause it and come back and see if you can get the same answer that I am getting. See, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Therefore, my answer is -5, because think about what this is asking. This is asking 2 to the what gives me 1 over 32. You can also work backwards. You can take that 132 and say, okay, I'm going to break this down. 32 is 2 to the 5th power. Now to bring it up, it's -5, and my exponent's the answer. Either way will work. All right, and so here's our last one that we're going to be working on. I'm going to go ahead and set this up as 2 to the what gives me 0.25, but then I realize that's not really helping me. I don't know. I don't know 2 raised to what is going to give me a 0.25. Nothing's popping out at me. So I realize, oh, just like I don't like roots in a log problem, I don't like decimals. And so if I went ahead from the very beginning of this problem and changed it to log base 2 of 1/4, then this one would be easier to solve, right? Saying 2 to the what gives me 1/4. Well, first off, I know if the 2 all of a sudden jumped to the denominator, a negative is at play. And I know that 2 squared gave me 4. So my answer is my exponent always, right? Log's answer always is what the exponent is. And so there we go. Let's try one more of those. And we're good. Go ahead and write it down. Pause, and then let's come back and check our answers. Okay, so once again, just like I don't like roots in my log, I don't like decimals. So whenever possible, I'm going to change my decimal to a fraction. And I know if 0.5, right, 0.5 is 1/2 and 0.25 is 1/4, then it would make sense that 0.125, right, half of 0.25 is going to be 1/8. And then I'm going to set up my little box and say, hey, 2 to the what gives me 1/8. My 2 dropped down to the denominator, so the negative is at play. And I know 2 times 2 is 4 times 2 is 8. So 2 cubed is 8. And once again, my answer is the -3. So hopefully that helped. I know that these were deceivingly difficult, right? You look at them and think, oh, they're little, they're easy, but they're not. You have to know several things and be able to put them together to be able to do this. So if you need more help, go to the 3.1 lesson and watch that, and complete all of your work that I've assigned to you, because there's plenty of practice in this, of these problems in the day 1 review, the review day 1 homework. So go ahead and do that, and I look forward to seeing you in class where you will show up and get an A on the Chapter 3 test. Thanks for joining me.